All right. So we're gonna do antiderivative. Let's wait a couple more minutes, and that would be the last topic of this semester. All right. So antiderivative. One of the things we're gonna look at. All right. So all throughout the whole semester, we looked at if I give you 2x squared, what's y prime? You get 4x. All right. What about y equal 2x squared plus 3? What would be the y prime in this case? Still, we'll get 4x. What if this was 2x squared plus 100? Again, you would get all of them to be the same. Okay? Now, what if we want to go from y prime to y? How do we go about doing that? And that is called antiderivative, or also known as an integral. Most of you have already seen that. If I give you f prime of x equal 3x squared, what would be f? Most of you kind of got an idea, and you would say x cubed, right? Because when you take the derivative of this, you get 3x squared. Now, what's the rule for that? Antiderivative. This is the symbol for integral for all inside the interval. That's called integral or antiderivative. Well, but we have a problem for this type of thing. Well, we know f prime of x is 3 squared. F could be x cubed plus 10, or it could be x cubed plus 100. We don't know what it is. So therefore, this constant, we don't know this constant. And we call this constant c, the symbol for c. So if I give you antiderivative of 3x squared dx, then the integral of that would be x cubed plus c. But what is the formula though? So here's the basic antiderivative formula. X to the n dx equal x to the n, that's where you have that plus 1, n plus 1 plus c. These two are the most important part. So if I go back and look at that problem, 3x squared dx, I would rewrite it as 3x to the 2 plus 1 over 2 plus 1 plus c. And if I reduce that, this becomes what? x cubed plus c. That's it. Simple as that. Now from that, I'm gonna give you some trig functions. Cosine of x dx will be sine x plus c. It's kind of like opposite of derivative. The negative and positive kind of changes. The sine x dx equal negative cosine of x plus c. This one you get secant square of x dx equal tangent of x plus c. A lot of them you're gonna learn it in calculus 2 how to get that. I'm just giving that to you for now, but later on you will learn how to do that. Cosecant square of x dx equal negative cotangent of x plus c. And then the last one is cosecant x cotangent of x dx equal negative cosecant of x plus c. So let's try some problem. For x cubed plus 6x squared minus 3dx. And we could individually do that. 4x cubed dx plus 6x squared dx minus 3dx. And we could use that formula right over here. 4 plus x to the 3 plus 1 over 3 plus 1 plus 6x to the 2 plus 1 over 2 plus 1 and minus, and the antiderivative constant will be just x, because you have what? X to the 0 plus 1 over 0 plus 1, and don't forget the c. Now if we simplify it, you get x to the 4th plus 2x to the 3rd minus 3x plus c. All right. So let me have you guys try this couple of the problem. All right, do the antiderivative for these. Oops, oh my god, what am I doing? Plus, oh, sorry. Oh my god, what am I doing? X squared dx, there you go. All right, do the integral for that. Hello, Slade. I'll give you a couple more minutes. All right, so let's look at this. That's again, I'm gonna rewrite it. To make my life easier. So therefore that's plus 1, negative 3 plus 1 plus x squared plus c. So if we simplify that, minus minus cancels out. So you just get x to the negative 2 plus x to the third over 3 plus c. All right, that was easy. This one, just multiply it out. 4th plus x to the third dx. So therefore this get x to the 5 over 5 plus x to the 4th over 4 plus c. All right. All right, let's try some other one. So these are known as indefinite integrals. Basically what it does, basically if we have a function, let's say you have this type of function, and we want to know what's happening under the function. Derivative gives you the slope of the tangent line, but integral will give you the slope of the area under the curve. So indefinite integral, we don't have endpoints. So let's do one more. So if we look at this one, let's rewrite it again. Now let's do the antiderivative of that. I get 1/2 plus 1. I get 3/2. 1/2 x to the negative 1/2 plus 1. I get 1/2 plus c. Well, these cancels out, and I get 2/3 x to the 3/2 plus x to the 1/2 plus c. I'm just gonna leave it like that. Now for the definite integral, you have endpoints, and we want to know the area under the curve, and that's the whole purpose of integral is. we want to know the area under the curve. So the way it works is, the rule for that is, where is the first fundamental theorem of calculus. Oh my God. Let capital F of x is the antiderivative of f of x dx, then if we want to take an integral where b is the bigger number and a is the smaller number of f of x dx, then f of b minus f of a. That's the little bit tricky one. So we're not gonna do the Riemann sum and those things. So basically, if I give you this function, one, two, three, 3x squared plus 12x minus 9 dx, what that means is if I graph this function roughly from 1 to 3, the graph kind of looks like that, and I want to know the area over here. So easy way of doing that problem, let's do the antiderivative of that. Over 3 plus 12x squared over 2 minus 9x. For a definite integral, we don't have any plus c because I'm giving it the exact function. We want to know what's happening, what's the area under the function, okay? From 1 to 3. And we're gonna do more of this problem later on. And then I'm gonna show you the integration by substitution. We're gonna do that a little bit later. So in this case, if we simplify that, I get negative x cubed plus 6x squared minus 9x from 1 to 3. So now we just plug that in, negative 3 cubed plus 6 3 squared minus 9 3. Now we got to do the subtract of the whole thing. Negative 1 cubed plus 6 1 square minus 9 times 1. So if we look at that and if we simplify that, you'll get right over here, you'll get 0 minus negative 4, which becomes just 4. Now you're gonna get some problem where you're gonna get some negative answer, and that's the one that I'm gonna help you understand in next class. Is when we're finding an area, why do we get negative answers and things like that? So rest of the next 3 weeks, that's what we'll be doing, is just going over integrals, and that's what we'll be doing. So I barely touched it a little bit, so you can start working on it, and then come back on Wednesday with a lot of your integral questions, and we're gonna do all integrals from now on. All right, so I just gave you the touch of that. I'll be on computer to answer your questions, so don't worry. We're doing basic integral, nothing hard yet. Then we're gonna come back, do all the crazy integrals.